right, so our agenda for this week is today we're going to do your double and half angle identities that are on your formula sheet, and then we're going to get into solving some trig equations. That carries over to tomorrow as well, and then we'll see if we can kind of tackle some of that review before you leave tomorrow, if time permits. You have a substantial amount of work this week, and one of your due dates is a little bit different just because you do technically have Monday off. So you have your 3 homework assignments as usual. The review assignment, this one, I'm kind of hoping we have a little bit of time to start tomorrow. And then your test for this chapter, I bumped to be due next Wednesday night instead of Tuesday because you're off on Monday. Okay? So please don't wait till the last minute on those assignments just in case you need help or need to reach out, especially with no school on Monday. Okay? So make sure that you are able to reference that. That's posted on Classroom for you as well too. And what we're going to talk about today is on your formula sheet, we have discussed up to this point your reciprocal identities, your quotient identities, Pythagorean sum and difference. And today we're going to talk about the double angle identities and the half angle identities. Okay? But calculators in front of you for sure, just to make sure that you know how to type all of these items in. All right, so number 1, I'm going to give you a problem that has 4 different parts to it, okay? So I'm going to go 4 different parts. All right, so your first section is, again, 7.4 with your double and your half angle identities. So number 1, I want you to write down, and there's a lot of detail with your notes today too, so try not to smush your problem so you can kind of refer back to these. So I am going to do that cos of x is equal to, so we are going to go cos of x is equal to, and I want to go -7/8, and it's going to be located in quadrant 2. So this is located in quadrant 2. If the question's not worded like that, what could also be said for quadrant 2 is that your angle is between 90 and 180. So you could also see this notation too. I'm going to put it up there for you, again, just in case. So you could see this. And what I want you to find are 4 different items, okay? So we are going to go through and find, and again, I wanted to use one problem to kind of work you through a bunch of formulas. So letter A, we're going to start and find sine of 2x. And then we're also going to find cosine of 2x. So we're going to do some double angle identities. And then we're going to do tangent of 2x. I'm going to go tangent of 2x. And then lastly, I want you to determine what quadrant cos 2x lies in. So determine the quadrant. Determine quadrant for, and I want to go cos 2x. Okay, so all 4 of those questions are going to go with this. Okay, kind of like you did last week. The smartest thing to do with these is to begin by drawing the picture. Okay, so on the side here, I am going to sketch a triangle located in quadrant 2. So I'm going to go over here. And we're going to go second quadrant triangle. Again, every single time. Now I'm going to label what I have on this. I gave you the value for cosine. So here's x. Cosine by definition is adjacent over hypotenuse. And clearly we know one of those is negative. A hypotenuse is never negative because it's the result of Pythagorean theorem. But this side, I went left of 0, so this is my negative. That would be -7 and 8. Okay. I'm going to do a quick Pythagorean theorem here to get my third side. So third side Pythagorean theorem would be square root of 15. Again, always do those kind of somewhere off to the side because you're probably going to need all three sides of this triangle anyways. Okay, so the next thing I'm going to do is draw your attention to your formula sheet. You're going to go into where it says double angle identities because we're doubling the x value. So I'm going to go the sine of 2x. So here's part A. So sine of 2x is equal to, and you don't need to memorize any of these, 2 sine x cos x. So this is 2 sine x cos x. Do you guys notice on the formula sheet when you look at it right now how cos of 2 theta has 3 of them? Okay, and sine of 2 theta only has 1, and tan of 2 theta also only has 1. So I'm going to plug in now. So I have 2 over 1. And then I'm going to go to my picture and I'm going to pull off the sine value and the cosine value. So the sine of x comes right from my diagram. Sine is opposite over hypotenuse. So this would be the square root of 15 over the hypotenuse, which is 8. Now I'm going to do cosine of x. So cosine is adjacent over hypotenuse. All right, and then all you do is just do this little calculation and you're done. So my answer is -7 times 2, so that's -14, times the square root of 15. And I tried to deliberately pick a lot with radicals because I know some of you said the radicals were the tough ones when you did homework. 1 times 8 is 64. But all these answers have to be simplified as far as possible. And would you guys agree I can divide by 2? Yes, I got to go one more step and then I'm done. So my final answer, divide by 2, would be -7 times the square root of 15 over 32. And then all over 32. Okay, done. How's that first one? Not bad? Good. They're very formula based. These are what we used to teach in A2 trig. So again, these are not anything terribly difficult. You just want to go through your steps nice and slow. Now letter B. I am going to have you calculate cosine of 2x. And if you look at your formula sheet, you will notice that there are 3 different identities for this. So you can pick whatever you'd like because you have the whole triangle already solved. So you would be able to utilize any of the formulas that you want. I guess for simplicity, I'm going to just grab the first one. So we go 1 minus 2 sine squared x. But again, you can use any of those 3 formulas to do this question and you're going to get the same answer. Now I plug in. So I go 1 minus 2 over 1. And I would encourage you to do that because these next values are going to be fractions too. And then when sine is squared, it means write it twice. So for sine, I'm going to plug in and go to my picture again. Opposite over hypotenuse. So opposite is square root of 15. And then hypotenuse is equal to 8. And then square root of 15 over 8. Now I keep going. The nice thing is with a radical, when you have a radical times itself, it cancels out. So all you need to do is type that entire thing carefully into your calculator. Okay, so please do that right now. Try it. Then you'll know if you are able to get this answer correct or not. So this can go into the calculator because the radicals will drop off. Otherwise, you'd have to do it like the last one. I get an answer of 17 over 32. And then done. All right, nice positive answer. So cos of 2x was a positive value. So I'm going to do this for a second because we're going to need to find that in a minute. So cos of 2x just came back as positive. Okay, how do you guys feel with the first two so far, okay? Very formula based. Now, I can't fit my work for tan of 2x on this slide, so I'm going to flip it. But before I do so, look at your formula sheet. What ratio do we need to do tan of 2 theta? Don't we need tan of theta? Yes, guys, what's tan of theta that I'm going to use on the other side? Opposite over adjacent. So square root of 15 over the -7. I'm going to try to remember that, but we'll see how it goes. All right, so letter C is next. And I wanted to do tangent of 2x. Right off your formula sheet. Tan of 2x was 2 tan x divided by 1 minus tan squared x. So this is equal to, I'm going to go 2 over 1. Then I'm going to grab the tangent value from the other side. So if I look back at my triangle, I forgot it already, I'm sorry. It was negative square root of 15 over 7. And then all over, I'm going to go 1 minus, and I'm going to write that twice, which is great because a radical times itself cancels off. So this is going to work out really nice for you in the denominator. So that means the denominator can get typed right into the calculator, but not the numerator. Okay. So in the top numerator, I have a -2 radical 15 over 7. That's my numerator. And my denominator is calculator. So pick up the calculator, and what do we get from the denominator? Let's see. I got 34 over 49 for that. And again, just make sure you're able to get those values. Next, I do keep, change, flip, and then simplify. So I'm going to do -2 radical 15 over 7 times, flip it, 49 over 34, and then cancel. So divide by 7, divide by 7, divide by -2, divide by -2, or just divide by 2 actually, and then good to go. So answer would give me a -7 radical 15 all over 17. Okay. How do you guys feel on those? A lot of radicals with these, okay? Take your time on the algebraic work in the middle there, because no decimals will be accepted for those. Okay, the last part of this question I gave you is I asked you to tell me where cosine of 2x was located. So I'm going to need to flip back in a second, but before we do that, if I'm not mistaken, I told you that x was between 90 and 180. So therefore, a double angle means multiply these by 2, and that means I'm going to be in either quadrant 3 or quadrant 4. Okay, so this tells me that I'm either quadrant 3 or 4, and we need to narrow it down to which one. So what I'm going to do is go back and take a peek at the answer we had gotten for cos of 2x to determine if it's positive or negative. So you're going to pull back the information you learned before about ASTC. And what we know is that cosine is negative in the third and positive in the fourth. Okay, so I'm gonna just flip and figure out what did we get. So cos of 2x, was it positive or negative, guys? You remember? Positive, yep, so what's the answer? Quadrant, exactly, yep. What was it, 17 over 32? Okay, thank you. Just so you know what this went with, was equal to a positive 17 over 32, which clearly indicates quadrant 4. All right. How's the first one all the way through? Pretty good? Okay. Next problem, I want to give you one with the half angle formulas. So those are on the other side of your reference sheet. And again, you guys stop me if you have questions, especially with that simplification process too. So number 2 all the way through. This one's much shorter. All right, so I want to tell you that cosine of theta is equal to 3/4. So it's positive. And I want you to find me the positive value of sine of 1/2 theta. So what is the positive value So what is the positive value of sine of 1/2 theta? And hopefully this goes without saying, every answer you do is going to be simplest radical form. So I'm not going to write that up there. Okay. On your formula sheets, do you guys see where it says sine of theta over 2? Do you notice in the front of it how it has a plus and a minus sign? You guys see that? In our case right now, which one are we using? Just the positive, okay? So sometimes you'll use the positive, sometimes you'll use the negative. So I'll give you one of each today. So we are going to do that sine of 1/2 theta is equal to the positive, because I told you so, and square root of 1 minus cos theta over 2. Now, for most of these examples that we've done the last 2 weeks, you've drawn triangles. Do you actually need to draw a triangle for this one? Or do you already have the information that you need? We already have it. So all you gotta do is sub it in. So you do not need to draw a triangle for this one if you don't want to. So I'm gonna go 1 minus 3/4 over 2, like this. Don't type the square root, please, but type everything that's underneath it. So go 1 minus 3/4 divide by 2. And what you should arrive at is the square root of 1/8. And then we're just going to simplify this. This is equivalent to the square root of 1 over the square root of 8, just in case you forgot that. So the square root of 1 is just 1. And then the square root of 8 simplifies into 4 and 2. So the square root of 4 is 2, and then radical 2. I'm going to rationalize top and bottom, and then there's my answer. So you've got to rationalize all of these, and this is equal to the square root of 2 over 4. I tried to, again, deliberately pick a lot of examples with radicals, because I think those tend to be the most challenging for you, and you probably need the most practice with them. All right, how do we feel on those so far? Good? Okay. Nice, quick, easy one. All right, so number 3, a little bit different, a little bit more work involved. So I want to go that sine of x is equal to. So I'm going to go sine of x. I need more space for, we'll be able to fit it, I think. So sine of x is equal to 0.7. And I'm going to tell you we are in quadrant 2. So in quadrant number 2. And I want you to find cos of 1/2 x. So find cos of 1/2 x, again, in simplest radical form always. Okay, so what you're going to do with this is you are going to look at your formula sheet and see if you need to draw a triangle, which most of the time you do. Cosine of 1/2 x utilizes a cosine ratio. You don't have a cosine ratio, so you must draw the triangle. So I'm going to draw a second quadrant triangle. Second quadrant. Now, when I go to set up this triangle, 0.7 is not really that helpful. Trig equations should usually be written as ratios instead. So 0.7 is what is a fraction? Isn't this really 7/10? That's what you guys want to use. So opposite is 7. Hypotenuse is 10. Pythagorean theorem would be 100 minus 49, which would give me the square root of 51. The other thing you want to be careful about is we are left of 0, indicating a negative. You are left of 0. Next, I need to determine which formula to use. Do I use the plus or do I use the minus? So what you want to think about is where are we at currently? So your x value is currently between 90 and 180. Half of that means I'm between 45 and 90. So what quadrant does that put me in instead? Quadrant 1. Okay. The next thing you want to think about, and this is a lot of thinking, so please write all this down because you have a lot of different thoughts that go into this. Now you're going to ask yourself, in quadrant 1, is cosine positive or negative? Cosine is positive. So for the formula, you're going to use the positive. So that is how I just arrived at that. And now we go up and solve. Okay. That's all that thinking that leads you to this. So cos of 1/2 x is equal to the positive, because we just discussed that, and then I'm going to go square root of 1 plus cos of x over 2. And please be careful and watch this algebra closely because this gets complicated. I'm going to start and plug in values here. So this is equal to the square root of 1 plus cosine of x is adjacent over hypotenuse. So that would be equal to negative square root of 51 over 10. All over 2. No, you can't type this in the calculator. Okay? This is where it's going to get a little bit nasty, I'm not going to lie. So you have a common denominator that's needed in the top here. If this is 10, I'm going to rewrite 1 is 10 over 10. So this is equal to the square root of 10 minus the square root of 51 over 10, because that's common denominator for the top, all over the 2. And this root goes the whole way. It's just sometimes hard to anticipate how big to draw it. So let me extend this a little bit bigger. Make sure your root goes over the whole thing. There we go. Now, what I'm going to do is keep, change, flip, okay? So here's my numerator. And my denominator is technically 2 over 1. Okay, this is my last step. So this is equal to 10 minus the square root of 51 over 10 times, flip it, 1 over 2. And yes, that's in here still. Okay. Now on the bottom, all I'm going to do is 10 times 2, which is 20, and this is my answer. So my answer is 10 minus the square root of 51 over 20 with a square root around it. Done. That is what we consider simplest radical form. So there is a square root underneath the square root. Yes, you can have that. So this here is my big answer. 51, lucky for you, does not break down, so you can kind of leave it like that. Okay, questions on any of those so far, guys? Okay, I'm gonna just keep going and give you some more. More practice, and the more of these you see, the better. I'm gonna give you another radical, because again, the radicals do get difficult, but it's not as difficult as that one. Okay, so over to number 4. So I wanna go, cosine of theta is 4 over square root of 22. All right, so number 4. More examples, and the more repetition you see, the better. So cos theta is 4 over the square root of 22. That's your ratio. And theta is in quadrant 1. So, and theta is in quadrant 1. Find, and these are always exact value, but I'll just write that again just so you know. Exact value of tan of 2 theta. So find exact value of tan 2 theta. But again, good, nice, detailed notes for these today, because these get complicated as far as the different steps involved here. So I'm going to begin, and I'm going to draw a triangle in quadrant 1. So quadrant 1 triangle, and I'm going to label what I have on here. So I have theta, and then I have adjacent over hypotenuse. You're going to do Pythagorean theorem to get your missing side. So 22 minus 16 would be the square root of 6 is my other leg. Find the value of tan of 2 theta. All right, so tan of 2 theta on your formula sheet is equal to, and that is 2 tan theta divided by 1 minus tan squared theta. You guys imagine if you had to memorize all these? They wanted you to a couple of years ago, but luckily they the state kind of changed their mind on that. And like, what purpose would that serve to memorize that whole sheet just for one chapter? All right, so I'm going to plug in, and I do 2 over 1, and then tan of theta is opposite over adjacent, and then the bottom is going to be 1 minus, and then tan squared. So that would be square root of 6 over 4, square root of 6 over 4. And the bottom is the part you can type in the calculator because the radicals go away. So this is equivalent to, well, if you want to do this, the 2 cancels with the 4 to give me a 2. So the top part is radical 6 over 2. And the bottom, if you guys type 1 minus and the product of both of those fractions, that comes back as 10/16, and 10/16 reduces to 5/8. Okay, almost done. I'm going to do keep, change, flip. So I get the square root of 6 over 2 times 8 over 5, and then simplify, and then done. So divide by 2, and that's 4. So answer would be 4 radical 6 over 5. Done. Again, I'm trying to work your brain and pick the radical ones on purpose. So hopefully it's helping to see more of those. Okay, how do you guys feel down to 4? Pretty good? Okay. So our next section that we are going to start today involves solving trigonometric equations. Okay? Your first couple examples are going to give you 2 answers. And as we progress into the quadratics, you're going to get upwards of 4 answers. So your next section is 7.5, and these are called trig equations. And again, I want you to do nice, detailed, thorough notes, and I'm going to keep the order the same for you because there's a lot that your brain has to process to get you to these answers. Okay. A lot of little details and steps. So this is what your question will say for all of these, so I'll just write it once. So we are going to find all angles, so again, upwards of 4, from 0 to 360, that satisfy. Okay, so again, you should expect multiple answers. Most of these today are going to have 2, and then I think we'll do maybe 1 or 2 that has 4 answers. Okay. All right, so number 1, I want to go, and we're going to start with linear first. So these today are going to be beginning with your linear examples. So I am going to go 9 tan theta and plus 13 is equal to 2 tan theta plus 6. And here's how I want you to think of this. Pretend that this equation says 9x plus 13 equals 2x plus 6, and solve accordingly. So what would I do in that capacity? I would move my 2x to the left, so I'm going to do the same thing here. Minus 2 tan theta would give me 7 tan theta plus 13 is equal to 6. Minus 13 from both sides would come next. And then again, right now, just pretend this says 7x equals -7. What would you do? Divide by 7. So right now, I know that tangent of theta is equal to -1. And I want you to listen very, very carefully and closely. You're going to use the negative for one purpose only, and that is to determine where to place the triangles. You are not going to type the negative into your calculator. Okay? I'm going to try to reiterate that as many times as possible. So the negative sign is where you draw the triangles. So this. Use to draw triangles where tangents is negative. That's it. So where is tangent negative? Which quadrants? A, us, and the fourth. Okay, so you're gonna get 2 answers to this question. So 2 answers. The next thing you're gonna do is use your graphing calculator. And then next step is on calculator. You're gonna hit second tan of +1. Again, you are ignoring the negative now. And this is equal to 45. 45 is what we consider a reference angle, and you're going to use that to get the 2 answers. Okay? So this is my 45-degree reference angle. This is my 45-degree reference angle. So for this quadrant, I do 180 minus 45. And that is equal to 135. And my other answer is 360 minus 45, which is equal to 315. And then done. So those are both your answers. So solutions of 315 and 135. So that's how we're going to do all of these, and in that order, okay? But the negative is the part that students tend to mistake most often. All right, do you guys have questions before I give you another one? Okay, again, I'm going to give you as many as I possibly can because seeing them in the repetition helps a lot. That one worked out really nice, no rounding involved. The next one, we're going to round to the nearest 10th. Okay, so I'll give you one that we don't know an exact value for. So let's go, number 2, still linear, round to the nearest 10th. I want to go 7 sine theta plus the square root of 22 is equal to 0. And again, pretend that it says 7x plus the square root of 22 equals 0. So you're going to solve for x, which in this case is sine. So I have 7 sine theta equals the negative square root of 22 divided by 7. And I get sine of theta is equal to negative square root of 22 over 7. The negative is for the triangle. That's it. Where is sine negative? Just remember, 3 and 4. In the calculator, I then type second sine of positive square root of 22 over 7. And this is for reference angle. All right, this comes back as 42.1. And then I just find the 2 answers, and then done. So in quadrant 3, I'm going to go 180 plus 42.1. So first answer is 222.1. And then your other answer is going to be 360 minus 42.1. And that is equivalent to 317.9. How do you guys feel with those, okay? Okay, I'm going to give you one more linear type, okay? Let's do one more linear, and then I'm going to just do one quadratic today. That's it. We'll do more quadratics tomorrow. All right, so here's one more linear. example. I'm going to do a reciprocal for you. So number 3, let's go 2 cotangent theta plus 1 equals 0. And you're going to solve it. So I would have that 2 cotangent theta equals -1. And then I'm going to divide by 2 and get that cotangent theta is equal to -1/2. Because this is a reciprocal, you have to use that concept. What does cotangent go with? You guys remember? Tangent, yep. So you're going to take tangent and you're going to flip it. So this indicates, because of the reciprocal, that tan of theta is equal to -2. You're going to take the negative sign and use it for the triangles only. So your negative sign is used to draw triangles. Where is tangent negative? Tangent is negative in the second and the fourth. So those are my 2 answers, where they're going to be at least. Next, I use calculator. And I ask the calculator to do second tan of 2. And this is also not going to be a nice value. You can round this to the nearest tenth is fine. I got 63.4. And again, that is what we call a reference angle. Okay, so this is for my reference angle. And then I'm going to use the little rule to find the 2 answers. So it's just like the last one. So I am going to go 180 minus 63.4. And that is equivalent to 116.6. That's your first answer. And I want to go 360 minus that. So 360 minus 63.4 is equal to 296.6. And then done. Okay. Pause for a moment. Do you guys have questions on any of those yet? And again, I'm trying to keep them procedure-based for you and keep the steps in the same exact order. Because again, it's easy to kind of lose your train of thought here and figure out what needs to happen next. So always do them in this order. So last but not least today, okay, I'm going to give you what we consider a quadratic trig equation instead of a linear. So here's your last one for today. So this gets into our section on quadratic trig equations, and these can yield upwards of 4 possible answers. So these are what we call quadratic trig equations. These are going to be solved with factoring and or quadratic formula if necessary. Okay. So your first and only one for today, we are going to go. And I just want to give you as many practice ones as I can. I think it helps. It's hard to figure these things out on your own. We're going to go 9 cos squared theta minus 4 equals 0. This is quadratic because it's squared now. You want to relate this back in the past to when you had to solve 9x squared minus 4. What did you do with 9x squared minus 4? Didn't you factor it? Wasn't it 3x plus 2? And then wasn't it 3x minus 2? Well, believe it or not, you can do the same thing with a trig function. So I'm going to do difference of 2 squares factoring with this. So this would break into 3 cos theta plus 2 and 3 cos theta minus 2. Difference of 2 squares. Yes, you can do that with trig functions. You'll do a lot of factoring tomorrow with these. So all you do to solve these is you t-chart both sides separately and you draw 2 diagrams separately. I'm going to break them like this. I go 3 cos theta is equal to -2. Sorry, I'm trying to write cos there. Equals -2. So therefore, cos theta is equal to -2/3. I use the negative for my triangles. So cosine is negative in the second and the third. And then I ignore the negative. Okay? So in the calculator, you're going to type in second cos of 2/3, enter. And you're going to get your reference angle that helps you get the 2 answers. Okay, so this comes back as 48.2, which means my answers for this side are going to be 180 plus and minus those. So 180 plus and 180 minus, doesn't matter the order. All right, what do we get? I got, let's see, 131.8 and 228.2. Okay, now I go over to the other side. I was not ignoring it on purpose. We do this one. So I'm going to have 3 cos theta equals 2. Yes, it's pretty much the same thing. So cosine of theta is 2/3. So cosine is positive in quadrant 1 and 4. And that's where our other 2 answers are going to come from. I do second cos of the same exact thing. So you don't have to write it twice if you don't want to. And then my last answers would be 48.2, because first quadrant, you don't do anything in there. So there's one answer. And then I'm going to do 360 minus that. Okay, so I'm going to add to my list at the bottom here. So 48.2 was an answer. And one more, which was, I'm looking for it, sorry, 311.8. Okay, so that's a case where you've got all 4 of those solutions. Okay, how do we feel in those problems for today, guys? Good? Okay, tomorrow when you come in, we're going to pick up and we're going to do more quadratic trig equations. So more factoring, okay? Your homework assignments that I posted, you are actually able to do those first 2 deltas already. So again, I would encourage you to not wait to the last minute to do those, just in case you have questions or concerns. And then your test for this unit will be due next Wednesday night. And then midterm review next week.